then yeah, if you go to ICESAT data, which is the early data, ICESAT, and so the period is you see this is from 2003 to 2009. So you can zoom into any place. For example, if we want to zoom into, see, this is a zoom into the area. Then you can select put this bar. This is the bar. You can select the time period you want to use the data. So that you can use all of data or use some period of data. So the same thing, you can use more or less of the data. Okay, zoom in, and I think you need to zoom in to see the data. Also, yeah, you can zoom in. Oh, yeah. So if you zoom in more, you can see the data on the video on this one. So you can, yeah, here is, yeah, you can get more data or you can get less data. Yeah, and so you can see each point is an elevation. More, yeah, more. So you can see some point come to the ocean, have the river, some on the land. This some point here is on the glaciers. Okay, if you click, so they will tell you the ID, the track is 48, and this one is track 100. View track data, so then you can check the track data. So I'm not going to go to the detail on the ICESAT data. So we are going to more detail on the ICESAT-2 data. Okay, ICESAT data is old data. Unless you want to use historical data, you can use that. So let's go back to this one, ICESAT-2. If we click ICESAT-2, yeah, so then you zoom into ICESAT-2. So there's a different view. So one of the view, I think in the video. Oh, okay. So this different data set here. So 06, 07, 08, 10, 12, 30. I think that's what we in the morning in the tutorial. Or in the morning we actually talk about it. So the 06 is land ice data. 07 is sea ice high. 08 is land vegetation high. Okay, then the 10 is sea ice freeboard. The 12 is ocean high, and the 30 is inland water surface high. Okay, so this is the 6 data sets available in this altimetry, open altimetry. Okay, so if we for us, we can do a demo on this land vegetation high. Okay, so land vegetation high. So we can zoom into our area. But okay, before that, we actually can use different projection. So this is the global projection, and we can change to the Arctic. If you're doing the Arctic, you can use the Arctic projection, and Antarctica, use the Antarctic projection. Okay. And in the left here, this is the day. You can select different day, the data. Okay, so different day. So each one day you have a different track. So you can see the most available day right now is October 12, which is so this data set need like 40, 50 days to process to release the data. They do have the lookup data set, which is 2 or 3 day release, which is the some of the product for the 6 lookup data, ATL 06, ATL 07 lookup data, ATL 10 lookup data, but this data is not available from this altimetry platform, but it is available from the NSIDC. So that is 2 or 3 day average 2 or 3 day release. So for example, today you can directly get 2 or 3 days before data. 2 or 3 days. Look up data, quickly process it, and maybe have some error. But if you want to just do a quick look at what is the data, what is the change, you can do that. And that quick lookup data is not available from this open altimetry, but is available from the NSIDC. Okay. So you see, for this data, the maximum the recent data is October 12. So tomorrow you will see the data will be the 30. Then after tomorrow, then you will see the data available will be 14. So it's kind of I don't know how many days, probably like 2 months of delay the real data. Yeah. Okay. So yeah. So they yeah.
Is there a way to get data early?
Early? Yeah. No. Yeah. The early data is the lookup. Quick look data. Quick look data is 3 day release. 3 day release, but is the quick process. Maybe have some error, whatever. But you can get
the same or
all of most of this like 06, 07, 08, 10, 12, 30. I think all of this have a quick look data.
In the same open activity.
Not here is the NSIDC.
Okay.
Not NSIDC. Not here.
So, where can you find the sort of future path?
The future path. The future path is actually the path is more or less of follow this. Okay. So let's okay. So I want to let's go back to the geographical. Okay. Then let's come to our area. I think it is more interesting. Let's come to our area. But okay, before I come to our area, I think I want to show this one here, which is the modis imaging. So if you put the modis imaging here, then you can see some of the data is there's loss of cloud. So means you actually don't get a good data set. If you wondering why you don't have any good data, because there's loss of cloud. You see, here is that you have good data set here. So if we zoom in here, you see there's data set here, but you don't have any good data because of the cloud. Okay, the cloud. So this is a quick look if you can get good data for a particular area or not. Okay. So for example, this one, the second day, and this is October the 3rd day. Oh, this area you always. Oh, this is the land area. This is the land area. This is the ocean always. But of course, this is the land surface. If we want to look at the ocean, we probably want to use this data set. Yeah, you see, this is the data set for the ocean. Yeah, let's come to our area. So you see, let's go back to this land surface vegetation canopy 08. Okay, so looks like their cloud. I want to find a day there's no cloud.
You want to go like March.
March, okay, that's good. It's March or April. first. Ooh,
Almost.
yeah, almost here. Second.
Put like 8.
Hey, okay.
Right. So 15. We're in the field that time. So 15.
15, okay. Yeah, I think
Much better.
yeah, that's much better. Okay, so we can kind of zoom into this area. Where's our conception?
Right around there. Actually, like 36 degrees south. Oh, to the north. Go to yeah, right there.
Oh, here.
They actually have
Yeah,
Wi-Fi there.
there's a flag
Yeah.
here. This
Flag.
oh, this.
That's fine.
Ooh. Let's find a good day. Okay, this is a good day here. Yeah. Okay, let's zoom in more. Perception. Let's check. Oh, oh, come to today.
Change the day and the date. You went back to August 22nd.
Yeah. So why? Let's say what is the? I think is the is the March, right? Yeah. Okay. This day looks good. Yeah. So it's last. Oh, not last year. Yeah, 2 years before. Let's zoom in again. We have good data set here. Continue zooming. Yeah. So so if you so this is the 3 pair. So the left. I don't know if you click. Let's see. Yeah, click this one. You can see this is the one left, which is strong. This is one right, which is right is strong, left is weak, right? In this case, should be yeah, okay. Left is weak, right is strong. We can zoom in more. Yeah, so this is should be the 2. So GT2 left and right strong. Okay, and if you look at this one, this is the GT3. So the B this is the B 5 6. So it's the pair 3 left left is weak, right is strong. Okay, and here is the GT2 left and right. Okay, so let me see if you can. This slide. Yeah, I can make this slide so you can see more detail. Then let's go back to here. So this is left. The GT1 left, GT1 right. Okay, so you can see this is the track number, the latitude, longitude, elevation, segments, and the time, which is 2021, February 23, the 3 hour 21. So this is, I think, is a GMC time, GMT, and this is the B regions ATL 08. So you can see this elevation is on top of the ellipse soil. So you need to minus the local geology to get the real elevation. Okay, So then we can zoom out a little bit. Zoom out a little bit. Okay. So this is the 1 day of data. It's the current day.
So if you click on where it says view photon data, it's gonna give you the photos for that
Yeah. So
particular average.
let me see. Okay, that's to the point. So we can view photon, which is for that particular,
Okay, so the
which actually for the track is for that track, right? Let me see. Yeah, it's for that track area configuration. But usually what I do is I will select the area. So select the area. Oh, I closed that. Sorry. This is for the ICESAT. Yeah, this is for the ICESAT one. I need to go back. ICESAT-2. And I'll zoom into our area. So this track right now is a reference track. So your data is not really follow this track yet. So unless we start select the data set, for example, you just click this one, then you start to have data, which I think this is August 28, it's 27. There's already good data set. We can just use this one. But if you want to see all of the data, you just select any one of these to check. Okay. So then we can select the region, which is what I want to select. This region is let's select this one first. So 1B, which is or 2B actually, left to right, one pair. Okay. So if I select this one, view the elevation profile. So you can see this is from the south to the north, and then this is the ocean. Okay, so if we parallel, make this parallel.
So that's the ocean.
Yeah. So this part is the ocean.
And then so it's an ellipsoidal height of the ocean, like 20 meters.
Yes. It's soil high.
20, 22 meters.
Yeah, little to minus the geoid to get the real sea surface height. Yeah. So if you move here, you see this is from the ocean go to the land. Okay. So you see so it's the land. Or you can start from the land, go to the ocean. Okay, so then you have the left and the right. Which one is the left? So the blue or the green is the right, and the red is the left. So in this case, left to right, they are very similar. But they can be different because they are 90 meters 90 meters away. Okay, so we are 90 meters away. So because of this come to the area, you have the canopy, you have trees, so that's what we can look at the high.
For some reason, the plot is not showing up, only the map.
Oh, the map is not
In
showing.
the Zoom, in the Zoom.
Oh, I think that's what we because we show that I think we need to change the screen share the entire
Share, yeah, now share the entire.
yeah not just let me go back to
Stop share and
stop share.
share the whole
Yes,
screen.
show the whole screen. This one, right?
Yeah,
Yeah. So then everything we show here.
yes.
Okay. So then you can see this is because this is an 08, you have the elevation, then you have the canopy height. The canopy height is really the real high one now because it uses the elevation on the top of the tree minus the elevation on the land surface. So is a true high. You don't need to consider about the joint because the joint.
It's just relative.
Yeah, the relative. Yeah, the joint is already a minus is reduced. So
How did you get that?
how to get this part?
Flat?
How
You
do
show-
you actually select those points?
Okay.
You do a rectangle.
Okay, so let me close this one. And we can start from here again. So we can select yeah, so this is the selector, select the region, then select a region. I can select a little bit more to the, then view the elevation. Is anybody can get that?
Yeah, he's already.
Okay. Yeah. Yeah. So then I just need to put this to the side. Yeah. Okay. So this is the left and the right, and canopy high. So the canopy high can be anywhere from you see if you point one to here. This is of course is in the water. I think it is he identified as canopy should be long, but once this come to the land, this canopy high should be relatively correct.
So the classification is made through modis or the.
The is from the algorithm itself. They identify based on if you have land, then the elevation is higher than land. If you pass the vegetation,
But it's from an satellite imaging.
separately.
Because it's small, it makes sense that maybe the
Yeah,
size
that's
of the pixel
yeah.
or something like that.
Maybe there's an island there. I don't know. There could be an island. It is right. There's potential. There's an island there.
I don't think there is an island.
There's no island.
There is an island a little bit to the north. You see that.
Okay, yeah. But what is the? Oh, this is A to B actually. Is not right. Yeah. But this canopy high can be like, up to 39 meters. Is that true? 39 meters for the trees? 41 meters. Potential is right in that area.
Well, that'd be too high.
Yeah, I think that's where you can actually do some kind of validation in the local area. But yeah, remember, I think from the tutorial, you look at the NASA tutorial, they said because this is 100 meter segments, 100 meter segment. So all it is already 100 meter segment. It's not an individual pixel size, pixel footprint. So individual is 11 meter. Okay, so 11 meter is potentially okay for big tree, but 100 meter is really a mixed tree and land of different trees. So it's really difficult to do that if this tree is not really dense enough for area. But if we go to this area, you see, come to here, yeah. So then you see this is the area we don't see the 83. This is the probably is
That's part of the city.
yeah, part of the city.
That's actually here, no, that's.
Yeah, a little bit north. Yeah, yes, yeah. But anyway, so this give you some hints of data. Then ocean surface high. So this is the ocean surface. We actually have 3 points. So one is this one, one is this one, one is this one. Okay, and this one is treated also as ocean surface. Then this is the inland water. So there's some inland water here. Yeah. So this is probably there's a lake there. Maybe.
Where's some wetlands?
Oh, wetland. Yeah. 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 So inland water from anywhere 3 meter to 4 meter. Yeah, 3 meter, 4 meter. Yeah, inland water. Let's continue. What else? Okay. So and if you want to download this data, you can save this data. Yeah, not if you click this one, this is where you can download data as this figure as PNG, JPEG, or PDF, or you can save the data as CSV, XLS, or whatever. So that is you can download data, and I want to show you here is more important is the original O3 data. Okay, so this is the elevation profile, which is already the product, like a 100 meter segment or 40 meter segment, but for this this O3, which is individual phantom. Okay, so click this one, you will see this is the individual phantom. There's lots of phantom here. Okay, individual phantom, and so there's a confidence level. So high confidence, lower confidence, medium confidence. So if we click this off, all of these are high confidence. Believe this data is more or less correct. So this is the ocean, is very correct, is right. This is the, then you come to the land area, and this is the mid confidence, and this is low confidence, and this is noise, and this is the buff. Oh, noise buff. I think they actually cannot show here. Okay, looks like it's not showing anything. Oh, it's waiting. Wait there to become responsible. Okay, wait. I think there's lots of data. Probably just noise. Still wait. Okay.
So if you scroll down, there's an option for okay.
Yeah.
Find your example.
Yes. Oh, finally, this one. Bider is right. This is actually I want to talk because tomorrow when I want to buy this activity data from the open activity to the Google Earth engine, which is use this link.
Okay, the
Yeah.
API.
Yeah, here this API link. So if I click this one,
Yeah, it's still frozen. I would just close it.
Yeah. Yeah, okay. So why is this exit? Okay. Exit. Oh, he froze me everything.
Yeah.
Exit everything. Okay, I can do it again. In. Okay, so there's a lot of one here in this side. So I just want to see. I see this section. See a lot of them here. Okay, so this is the one passing the downtown area, right? Yeah. Okay, this is the one I think we more or less we just saw that. Okay, let's check this. So before I only see one track. So this time we can actually take two track. We can take 3 track also. Okay, let's take 2 track. 2 track with 4 beams, right? 4 beams here. So then you will see more information. Okay, so you can see this one is in the middle track, the middle 2 track. So you kind of from the land, then to the ocean, then to the land again. Okay, so this to the land again. But for this track is from the ocean, and from the ocean, then to the land. So yeah, so you can see this is the 4 track here is difficult to see that because they are overlapped together, right? But because we can check where they are on the map and also on this plot, so it's easy to see that. So they're correct, and this is on the land. which is 100 meters above the ocean, about the 100 meters. Yeah. Then, of course, this is the 2 left, right, the 3 left and the right. Yeah. Oh, this is the 2. Okay, so the center is the 2. This is the 3. Yeah. So the same thing, you can see this is Caribbee High. Yeah, this is Caribbee. Then this is there's small Caribbee here in the urban area. Okay, in the urban area, small Caribbees. Then ocean high. There's of course there's an ocean from this one. See. Inland water. Okay, so this you can see there's more inland water. Oh, so this is the ocean water. It's the inland water. I don't know. This is the inland water. They should not have so many water. Maybe do you see there's water here in this area?
No. Maybe you're lucky you hit one of them, all the lagoons, but I don't think so.
Yeah. Okay. Anyway, so
So what happens if you click on the API? It opens an
okay, that's right. Okay, let's open an API for example. This API. So click this one, then you can open this in another window. Oh, this is the code actually when we put it into Google Earth Engine. Yeah, so we can actually not directly open that. So it's it's not directly openable, but that is when we combine to Google Earth Engine. Yeah. Okay, so if we go up, look at the altimeter O3. So let's O3 data, the functional data. So you see there's lots of functions. So we can actually zoom in, more functions. This is the ocean, of course. So some of them probably the bottom of the ocean, because this is a very shallow land area. So 5 meters, maybe even 10 meters deep. That's very possible in this area. Then reset through. So this area, this is let me see what is this one. So this looks like a lake geo. Let me see where is this. Oh, it's here. This is not possible, right? In this
that's what I mean. I think maybe it's related to how the surface classification is made.
Yeah,
That's too low.
Yeah, that's too low in this area. And this area I can understand. This is the ocean, the bottom, but this area, this deeper, it's not.
That's unrealistic.
Yeah. So this is high. Anyway, so this is how you can see the data, and I think we can go a little bit to the glacier. Jan will look at the 1 hour or 2 days ago. We have to look at that. Which glacier, Jan? Where is the glacier you look at? This one? Further south. This one? Okay. Oh yeah, this one. You see, this glacier and this glacier, there's a track pass through.
That's me. Yeah, but it's all.
So available.
That's in.
Okay, yesterday we looked at the which data set.
That might be.
This one. Oh, this one is a little bit away. So this one. Yeah, this one. This one was very good. We looked at it yesterday. And if we just select this region and we see the elevation. Okay. So this is from the surface of the ice. So you have a little bit deep here, which is a lake probably. Then go to the top of the mountain, the range of the volcano, they come down. Okay, and this is really good indication. This data set looks very good for here. So this is really flat. Yeah, this is a flat inside this. Yeah.
Question.
Yeah.
So what's the difference between the right one and the left?
Yeah, the lateral. So one is the strong B, one is the weak B. Okay. So let me see which one is strong B in this case. So this 2B, okay. So you see the 2R, 2A, the R is the right, AR is the left. So this left right B is the 2B in one pair, but the distance between the 2B is 90 meters. So the 90 meters parallel beams, and so because they don't pass through the same points, the elevation can be. So you can actually calculate the slope when there is slope. Yeah, when it's slope. So this is very useful. For the ICESAT only one track, the old ICESAT only one track, you cannot see the slope from the side. You can see the slope from the direction of the satellite movement. But this one, since you have the 2 track, and you have a lot of 2 track in the 3 kilometers.
So that operation between the groups is always nice.
Yeah, always non-limited exact. For example, yeah, if we look at this one, they're not exactly. So you can see, but you really need to. There's lots of this one. Oh, actually, that's just the example. But if you look at the fountain, there's lots of fountain here, but you can use the exact fountains to calculate the slope. You see, there's lots of fountains. Yeah, we can zoom in.
So the blues are the more confident, right?
Yeah, the blue is the more confidence. Yeah, I see. The high confidence, medium confidence, and then this is the only. So every time when we show this figure, the fountain figure is either the strong or the weak B. So if we select the strong B, let's go down. Yeah, so this is the strong B, and if we select the weak B, which will be the weak B, so then you can export this data into Excel sheet and they can compare them exactly the pairs and each direction, every direction you want to look at and calculate the slope. So you can use a lot of functions to do that. Yeah. So
and then, sorry, again, just to clarify.
Yeah.
So you use those photos because when you use the other one, you're using the 100 meter salary.
yes, yeah. So photon is an individual is 11 each.
It's one single.
Yeah, one single one. Yeah, one single. Yeah. So if we zoom in, there's still a lot. Yeah. This is you can continue zooming. So right now, where is the surface? So they actually have an algorithm to get a surface, a featured surface. A featured surface. So we get it to the OA product. And the average or whatever.
They filter out certain things or the other.
100 meters.
They filter out or the other. The other.
They actually use kind of
You mentioned normal distribution.
yeah, for the CIs they have the Gaussian distribution, but for this one I don't know. Maybe Young, do you know that how they actually get the surface? Do you know?
You mean the
Yeah,
surface height?
For this all three data to get the 100 meter
How they
OA.
select which atoms
Yeah.
represent the surface.
So what algorithm or they use or just use a simple moving algorithm fitting?
Yeah. Actually, I'm not sure about that land surface height data, but I think they just use just kind of moving average for every 100 meters.
Yeah, probably. Okay, yeah, because we didn't look at this data more detailed. We look at most detail on the CI set. So for the CI data, for the 150 photon, how they get that 150 photon elevation represent that 150 segments, photon segments.
So for each distribution, height distribution from 150 photons, they calculate the Gaussian fitting line and
yes,
calculate
Gaussian.
the mean of that fitting line.
Yeah, okay, that's what I was yeah, we discussed. Okay, good, thank you, John. Okay, so I think that's yeah, if you want to export this data, you can just export the data here. Yeah, export data or export the preview. So I leave here for you guys to play. So is that the last for the altimetry part?
It's right.
Yeah. So yeah, I don't think we have time for you guys to try here. So that you need to try later on once you're kind of interested to do that. So but I'm going to move on.
Okay.
Yeah, to move on
Yes,
the GE. Yeah. Okay. So I think I give you a good start, and then when we come to the point we need to use this URL, then we'll come back here to just directly copy this one and put it to the Google Earth Engine part. I think that's what I did with Jen 2 days ago, and it works well. Anyway, close this one. Close this one. So I'm going to open the
Your PPT.
yeah, PPT. Yeah, this is PPT. So can we just
Try. Let's see if it works.
Yeah.
If not, we go to the other,
Okay.
method.
Share with.
You have to minimize that window.
Oh, minimize.
There.
But I need to. Oh, okay. Here. Stop share that one.
No, I think that you don't need it.
Oh, that's right. That's right.
Just
We
share
want
the
to
screen.
Yeah.
Try with that first,
Yeah.
and then just try with this. Oh, if not, we do the, okay, the previous.
Yeah.
Yeah, it works.
It works. It also works on the Zoom.
I see.
Okay. Okay. Good. So, so introduction to the Google Earth Engine, hands-on, and also combined with the Google Earth Engine with open altimetry. So basically, this is actually my student Young. He was he prepared, and I just put my name here. So my all credit go to him. So what is the GE? I think you probably already know that. So the Google Earth Engine is a geospatial processing service. So there's lots of data, multi-petabyte analyst read data catalog, high performance parallel computation, internet accessible application API, and web-based interactive development environment, okay, visualization. So if you played around with this, there's data sets, so lots of data sets, not include ICESAT-2, but there's lots of other data sets. Computation, lots of API, lots of app. Okay, so how to access GE? There's three ways. One is use JavaScript. One is use Python. One is use REST. Okay, so I'm going to introduce you today is Python. So JavaScript actually is very good because they actually have a directly visual. Yeah, so you can see there's a JavaScript API here. So you have the code. You can directly put the Java code in the center, and the left is all of the different functions, and the right is where you can debug and see where is the error, what the progress, and here is the map. So JavaScript in this is very good. Okay, but Python is more powerful one. People use much more. Python is open access, and there's lots of community development programs, applications, and included into the Python. Also powerful is the Google Earth Engine. Also have a called Colab. So they develop a Colab interface, which you can almost have a similar kind of interface like a JavaScript. It's not exactly like that, but you can also use almost similar type of function. Okay, from the Colab CO. Okay, so today our practice will also use Colab. So REST is I'm not familiar. I think my student said that he is also not familiar, so we will not cut that. So the Python API is through the local machine interface development environment. So because Java is web-based development interface, but Python is actually everything looks like you are doing this in the local machine, but all of the processing is in the cloud. Okay, so you install some of the function and the algorithm into your local machine, but apply to the cloud. The data is in the cloud. Okay, so it's Python API does not support visual output, require additional process to visualize output. So all of this data goes through the Colab. of course, Hansa has lots of advantage compared to the JavaScript. Okay, so you have is a high level program language, object oriented, and simple code, can be very simple code, easy to learn. There's a massive library and easy to debug, open source. Disadvantage is speed is a little bit lower compared to the JavaScript, and sometimes inefficient memory consumption. So especially when we do the images, big images, I think my student told me is there's a limitation of like because some of the images you need to convert it to the array, then you do the further processing in your local computer. Then actually it's not a local computer, it's also on the cloud, but Google Earth Engine have a limitation how much memory you can use there. So, I think there's some limitation because he used that Hansa for to track the iceberg movement in the Antarctic Ocean. So so the size of the image, there's a maximum, there's a limitation. I don't remember what is the limitation size, but we don't need to worry about that time.
After that, you have to pay.
Probably after that, you can pay maybe that. That's right. Okay, that's good. Yeah. Anyway, so there's lots of stuff we don't even need to learn all of this stuff, because once we start to look at all of the scripts, we can apply, use others code. You just need to know where to make some changes in your area of study, your data of use. Okay. So I don't know each of this detailed stuff, but I can effectively use this function to do some processing and get my data. Okay. So I mentioned the Colab, which is the Google Colab, which is a product from Google Research. It allows everybody to write, execute arbitrarily function code through the browser, and it is especially well suited for machine learning, data analysis, education. So we use different type of machine learning methods like artificial intelligence, neural network, and like random forest, supported vector machine. All of this method is directly oriented there. You just call the function, and you can do the process. Okay. So it's a hosted Jupyter notebook service on the cloud. So all of this Jupyter notebook they developed by Hansa, we can directly call and use in this platform. So it's a Hansa interactive programming environment, similar like the JavaScript integrated environment with the Earth Engine I showed you before. But once we use the Google Colab, very similar environment. You can do that. Okay. So also there's an advantage for pre-installed lots of library and can share the script on the cloud. And so the cloud, I will show you the scripts you guys can all save to your local Google account, so you can use later on. Okay. And you can also use some free GPU, TPU from Google Earth Engine. Okay. So let's do the hands-on tutoring. So we have 6 hands-on tutoring today. More go through. And so the first one we will talk a little bit of Hansa basics. Okay. So I'm not going to go details, and you just need to understand some basics. Assuming you have no idea about Hansa. But these basics is good enough for you to start. And Hansa function, how to define a function, how to call a function, and also then you explore, use the Google Hansa API to look at single images from different sources. Okay, Then we will start to look at the image connections, like Landsat, thousands images for each location. Sentinel 1, Sentinel 2, thousand images. You can call, directly use the code. You don't need to write your code. Just directly use my code, the code actually my student's code. And of course, he probably could not develop all this code because he was the ICESAT-2 factory. Okay. So he can copy the code, put it into together, and then you can easily do a time series change detection to anywhere else, anywhere in the world. You want to see the urban how they change, the tree how they change, and the temperature how they change. Okay, so we have lots of examples and we can follow. Then in the end, I will show you how you can collaborate, combine the ICESAT-2 from the open altimetry to the GE environment to see the overlapping with the ICESAT-2 track on top of the Sentinel-1, Sentinel-2, Landsat images to see the change. So it's, I think this is really powerful, and my student developed this in 5 weeks to help graduate students to learn how to do that. Of course, I didn't include all of them. There's other part of the lecture, include image classification, machine learning, and use different like algorithm with the machine, and so all of that part. The image classification part, I didn't include it here. But if you're interested, I can share that also. Yeah, it's anyway. So let's go a little bit. So if you click the first one, let's do that. So you should be able to get to here. So this one, everybody, you should save a copy to your Google account. So what you do is go to here and save a copy in Drive. Okay, save a copy in Drive. Will be you can edit it, and you can go through that. So because you cannot edit it by one, but you can edit once you save a copy into your local. So then you can do all of the editing and processing. So have you done that? Just we will go through all of it. Just save a copy.
Yeah, I don't have to.
Oh, you don't have to?
Yeah.
Okay. You guys have a link, or you want to? Yeah. You want to do it? Can you just save a copy? Yeah, just go to here, save a copy in Drive. Then you will see there's for example, if I do that, save a copy in Drive. So one is create a copy, then open the new window. So copy. So that is the one you will work on that. Okay, you will work on that copy of whatever. Okay, so of course I can also work on this one. For example, I just work on this one. So some parts of basically, so this we cover 4 different types. So one is the numbers, how Panzer actually define the numbers, then define strings, then define a list, and then define a dictionary. Okay, a dictionary. So that is the 4 areas we will cover in this very short term.
I'll share that link again.
Oh.
My OneDrive.
Okay. you just save will be saved to your local, yeah. You just save, yeah. Yeah. You need to log into the Google Google account. That's why you need to, yeah. And oh, okay. How about you? Oops. Yeah, use login. How about you? Oh, okay, you don't have. Yeah, so define number, of course, for example, oh, so here there is a plus, this is add a code, this is add a text, okay? So if you want to add a text, just say what is this, for example, I can add a text to here, this is for the workshop. Or for ICESAT and GE, something like that. Then you just click that. So then you add a text. So if you want to add a code, you just put your mouse to somewhere, then you can add a code. So we'll do that here. For example, right now I define A equal to 6. So I can add a code. I can define B, maybe a C equal to 50. Okay, so you can also put a annotation here. Okay, just set okay. I can actually, this is 6 is an integer. I can define this as a float. Set a float variable. So you can easily add a text, add a code. Okay, so that's a very simple. So once you want to execute it, if you come here, you can execute. Voila, A equal to 6. Then yeah, so means voila, A equal to 6. Then C equal to 50. So define that. So then you will see A is 6. Then B, okay. So then we can. So we can add a code here. I want to see. I want to know what is the C because I define the C. So what is C? How much C? We will tell you C equals 50. Okay. So this is a very simple definition of a variable and execute a variable. Okay. Then if you want to do, okay, A plus 2, of course, A is 6 plus 2 is 8. If you want to execute, yeah, it will be 8. Then this is define another one, B equal to 10. Okay, then what is A plus B? A plus B will be 16. Okay, so you see, that is a very straightforward function programming. What is A plus B? So you can do A plus B. So because we already have the C, so if I add a code, what is A multiply C. What is A multiplied by C? Okay. So then you execute. So will be 300, right? Because A is 6, C is 50. So A multiplied by C is 300. So once because you have one variable in the flow, then your result will be flow. Okay, that's so you can easily add a code, add a line here, or add a text here. So you can add another here, text here. So okay, execute A multiply C. Okay, so that's what will be here. Okay, so then you can do A divided by C, B, then you can redefine the A because A was 6, why not? We can redefine A as a float 9.5. So then A plus 4 became 30. Okay, so A plus 4 and 30. So once it's executed, so there's a check mark. If it's not executed yet, so there's no check mark. Okay. Constant is also case sensitive. So capital A and small a, they are different variables. Okay, capital A and small a are different variables. Okay. So for example here, the capital A is 4, the small a is 9.5. Okay, so if you want to bring the small a, which is 9.5, capital A is 4, A plus 4, capital A plus small a will be 35. So click this one, and this is the execute. Okay. Yeah. So string. So you can define a string. In string, use double quote or single quote. So you can see double quote, single quote in this case is the same. You can define your hello as a double quote or a single quote. They are the same. Okay. So you can use a double quote. They print A equal to hello. So if I change to single quote, they should have the same result. Okay. Define hello and print A. Yeah, so the same. Double quote, single quote, they're the same. So you want to here calculate the length of the A. For example, length of the A is 5. Okay. Define another string David. Okay. A plus B, which will be hello David. Hello David. So if you put an A plus 2, in this case we have A because A is string right now, 2 is a number. So the string and a number you cannot add together, right? You cannot add together. So unless you kind of redefine the 2 as a string, then it works. So A plus B is hello David. A plus 2 will give you A. Okay. So this tell you the A. This is A. A cannot plus 2 because A is a string, 2 is not a string, is an integer. Okay. So then if we change a little bit, put a string to convert the number to a string, then you can do the hello 2. Okay. So that is a very basic programming and very simple language, Python. So there's indexing. So indexing usually from 0. So start from 0. So 0 in this case, the 0 is H, the 1 is E, the 2 is AR, the 3 is AR, the 4 is O. Okay. So if we say okay, indexing A0, which is H. Okay. A2 is will be AR, right? A2 will be AR. Yeah. So how about A4? If we change to A4, will be, oh, sorry, change to A4 will be O. Yeah, will be O. Okay. Then so A7, because this maximum is 4. If you put A7, will give you A. Will give you A. Okay. So for example, this is if you put A4, because your index in this case is maximum is 4. You cannot put more than 4. You can put A7, will give you A. You can also do negative index from the back to forward. Okay, so -1 will be the O. -2 will be 1. Okay, for example, -1 will return a rate of 4. -2 will return rate of 1 AR. Okay, so this is A back to hello, A to 3. So this is a string from A to 3, from 1 to 3. From 1 to 3, 1 is E, 3 is AR. 1 to 3 actually is not too, it will be returned not exact to the 3. For example, if we go to 1 to 4, will return EAL. EAL, yeah, EAL. Let's see if 1 to 5. I think 1 to 5 it doesn't work because then because maximum is 4, right? We'll give 8. Oh, 1 to 5 actually is 0. Yeah, 0. Okay, 1 to 5 it works. 1 to 6 will give 8. Yeah, 1 to 6 will give 8. Oh, it still work. 1 to 6 still work. Interesting. Okay. So even though there's a low rate after the O, but it still work. It still didn't give you 8. So should be 1 to 5. Okay. So from here to 3, which will be the first 3, will be the first 3. Yeah. A 3 will be L, HEL. Anyway, so I think I don't need to go to details about this concept programming. You can learn itself if you already know, then it's very easy. So for example, text. So right now, this is the text. Hello, my name is Steve. If you put a text string, so we'll return actually individual words, individual word. Okay. Okay. So list is to define a few strings in that list. Okay. Use the square brackets. Okay. So then if so this list color, you have 3 different colors there, red, blue, and green. So if we want to print the color 0, index 0, which will be red, right? Index 2 will be green. Well, if we want to print the length of color, will be 3 index. So this is let's do that, and so that's what we got here. So numbers 3, 4, 5, 6, 7, 8, 9. So you can put a index 0 will be 3, index 2 will be 5, and index the length of this will be 7. Okay, so that's once you execute will be like this. You can do a for loop, and then you can do a for loop, and they add together, and also a while loop. Okay, while loop add together. So I don't know how detailed you want, or you can easily learn that by yourself. For while is a very normal in any kind of language, right? So for example, we can just do the for loop, for example. So for loop, here the for loop for number in the numbers bring the number multiplied by 2. So because we in the number we have a list of 3, 4, 5, 6, 7, 8, 9. If each number multiplied by 2, so in this case, each number multiplied by 2 will be 3. My 2 will be 6, will be 8, will be 10, will be 12, 14, 16, 18, right? So let's execute that. You will see the result will be 9, 16, 25, 81. Okay, multiplied by 2. Oh, this is not actually multiplied with the power of 2. I'm sorry, it's power of 2, double. 2 is power of 2. Yeah, is power of 2. Yeah. So this is the for loop to add them together. So the sum 0 for number in number, add the number together, then bring the sum. Okay, click this one. So you can see 3 plus 4 will be 7. 7 plus 5 will be 12. 12 plus 6 will be 60. 6 plus 7 will be 25. 25 plus 8 will be 33. 33 plus 9 will be 42. So the total sum is 42. Okay, so it's a very simple loop, for loop, and so here is if you have a condition, if the number less than 7, you add them together. Larger than 7, you don't add it anymore. Okay, so that's why it will be 80. Okay. So I think I want to skip this because this is a really simple, but you can extend or obtain your list. Okay, so for example, this is your list, color list. Okay, you have 3 colors, but you can extend the pink, brown into this list, then print the color, so it become red, blue, green, pink, brown. Okay, and you can also obtain this to here, print color. So you can see the difference between extend and obtain is different. Okay, extend, this color become part of this list. Extend is not part of that. The entire thing is obtained. So this is still one list added to this 3. Okay, so a little bit different between extend and obtain. Okay, then you can bring index green, which the index is 2. Green, the index is 2, right? Green index is 2. Green index is 2. Blue index is 1. Red index is 0. So if we say, okay, I want to print the red index. What is the red index? 0, right? Yeah, 0. Print the color index white, because we don't have the white here. So because we don't have the white in the list, So if you want to create an index for the white, we give you A. Yeah, because you don't have the white. Okay. Then we this slice the weight. So this is a print color 0 will be red, 0 to 3 will be red, blue, green, negative 0, negative 3 to negative 1 will be red, blue, and color 4 will be nothing because they don't, in this color there's no element in this list beyond the 4. So then this is the sorted function. Bring the sorted A will be from 1, 3. So this is the positive sorted. You can do a negative sorting from the backward. Bring A, sorted A. I don't know what is the from the maximum to this. I don't know if this works, but yeah, it doesn't work. So
because A is a list.
yeah, it's a list. Yeah.
Way.
So how we do the maximum to maximum to minimum? So I don't know the function sorted, the inverse sorted. How's the inverse? Okay, false is inverse, so we can add a return list control item in ascending model. Reverse back can be set to the descending model. Reverse back, where we put that, we put it here, reverse. I don't know how to put it reverse.
It's before the Mac, before your one. Before sort.
Before sort?
Right after the A.
Right after the A.
Right after the letter A.
Reverse, okay. I-V-E-R-S-E. Okay. Then let's get that.
Equal sign.
Oh, need the equal sign?
Yes, the equal. True.
Oh, true.
It's title.
Works.
I think it's titled. Yes.
True with
With the capital.
oh, true will cap. This one?
Yes.
Oh. Yeah. So he can better than me. Okay, good. So Python is a symbol to learn. Okay, this is string A, B, B, Z, Z, C, C. Sorted, we can also do a reverse. Okay, so oh, this is actually the example here. Reverse equal to 2. Okay, so I skip this. So the dictionary, which is a little bit different. Dictionary is use the curly brackets. So the list uses the square brackets, but the dictionary is curly brackets. Okay, so we can define alpha is a dictionary, and then we can store it. Alpha into A, gamma into G, and omega into O, for example. So this is the dictionary. Then print alpha. A is for alpha, G for gamma, O for omega. Then if you want to looking for alpha O, which will be omega. Yeah, alpha O will be omega. If we want to add a code here, for example, I want to add a code alpha beta will be with alpha G, then skewed G will be gamma. Okay, so then print A will be alpha, then alpha beta will be A equal to 6, because I redefine alpha A equal to 6. Okay, so now if we ask for alpha beta, will be A equal to 6, represent 6, G represent gamma, O represent omega. Okay. This is for key. So this is a for loop. For key in alpha, print key. For key in alpha, key for key print key print. Yeah, let's do that. Then the result is AGO. Diction key is AGO. Diction value is 6 gamma omega. So 6 gamma omega value. Anyway, so I think this is a very simple start for the Python basics. And we talk about basic numbers, basic strings, define a list, define a dictionary. Okay. Of course, there's many more stuff in the Python, but you don't need to know everything Python before you can run the GE. Okay, so we will start. Okay, so we will start the. What was the time right now?
We're like 25 minutes.
25 minutes. Okay, so we can do the second one, the functions. Yeah. Second one. Yeah, so Python function, how to define a Python function. Maybe you can, yeah, I think this will be really fast to do that. Then we can go to the number 3, most important stuff. Okay, so to define a function, so the same thing, if you want to do that, you need to save, okay, save a copy and drive, and then you can work on that, okay. So to define a function is use this def function name called hello, and put the name there. Okay, for example, define a function hello, and to hold the range, so then print od plus name. Then you if you run this function, put the name the term, then will output a od count. Okay, so you can see this function. There's no output. There's no output. No return. There's a lot of type of function. There's return. Okay, so this one is define stuff after you return something. Okay, so this is a lot of type of function. For this type of function, there's no return, and this type of function there's a return. Okay. So define a repeat s times, and the result is s multiplied times, and the return the result. Okay, so then let's run that. Define this repeat function, and then we call this function a equal to repeat while for. So while is here is like a list, right? Or string. Then Yeah, this is 3. Then the number 4. Okay. Then print. So define A equal to repeat. Then how many times you want to repeat? Okay, yeah. In this case, 4 times. Then this is the function. The function calculates AGVI. Okay, AGVI define factor return near infinite minus weight divided near infinite plus weight. So this is in the remote sense is very important in GVI. So define will return the info return into, so we the near infinite equal to 0.7, weight equal to 0.3. So the return AGVI will be 0.4. Okay. So it's a little bit weird. It didn't directly give 0.4 by 0.39997. Then this can input a library. There's lots of console library you can import. For example, this is import a NumPy library as NP. So then you can first import the library. Then you can execute A equal to the array 2, 3, 4. B equal to array 4, 5. So is define array, 2 arrays. Okay. Then you can print the A, which is array 2, 3, 4. Then this is to call the arrange function. Arrange function 10, 32, which create an array from 10 to 30 with a step of 2. Okay, create an array from 10 to 30 with step of 2. So we'll start from 10, 12, 14, 16, 18, 20, 22, 26, 23, 26, 28. So maximum will not always, will always less than the maximum. Okay. Then this is a delta. So this is called arrange from 0 to maximum 1 with stable point 0.05. Then multiply another actually constant pi 3.14, 15, something like that. So they bring the delta equal to the range. Each number will be multiplied pi. Okay. So then if you execute that, you print the numbers from 0 to maximum 2.98. Then you can also call the other function cosine, sine, tangent. Calculate the numbers. This is called a reshape. So to rearrange this array from 0 to 11, okay, 12 numbers, then from 4 to 3 or 3 to 4. So 4, 3, 4, 4 rows, 3 columns, 4 rows, 3 columns. Yeah, 4 rows. If you change this to 3, 4, it will be changed like this. Okay. Or you can change to 2, 6. Oh, yeah, 2, 6. So 2 row, 6 columns. So this is a simple code. This is called a number. So this is the sum. all of the value add together. So you don't need to add use a loop. You just directly use the sum function will be added. This number together added will be 66. Then this is an array sum B for 6 x a 1 for sum 0 for the column B x is not 1 1 to 50. Then around this mean of B will be 5.5 and mean of B will be 2.58 standard deviation and minimum maximum. Okay, so the loss of function you can simply just call. Okay, you don't need to write a for loop or while loop. Okay, so I think I finished this part here. Let's start a little bit on the real stuff. GEE. Okay, so this is the real stuff to start with the Google Earth Engine with the core line. So we will start a little bit. If you have time, you can go home to run yourself. Okay, the same thing you can save to your local job to your GE account. Okay, so I think we already mentioned what is GE and the objective of this one is to explore the GE map for mapping image data, to import or visualize single band, multi-band image, and explore some basic information from image, which is for this module. So, like I said, the GE is different from the JavaScript because the JavaScript have directly in that interface environment in there, but the Python don't have. But Python have the GE map and have other stuff help us to get that similar interface. Okay, so we need to install the GE library. So this is if we click this one, we start an install. Every time we start a GE processing, we need to install the GE map library. So every time. Once you start a G programming and processing, you need to install this one, okay, to your local computer. Once it's finished, we tell you it's finished. Yeah, so successfully install the GE map. GE map, yeah, okay. So everybody can successfully do that. Oh, you're not enough. Okay. Can you do that? Okay, finish. Okay, good. How are you? Yeah. Yeah, just money, good, success. Okay. Money, good. So once you finish that successfully, then you can open the basic map with G library. So we import the G map, import the Google Earth Engine. Once we finish that, we need to do the authentication. Every time we also need to do this. Okay. So click this one, authentication. So we'll go to, we need to click this one to get a code. Okay, click this one, click this link. So then we'll go to your Google authentication. Okay, then you will generate a token. Then you select your email account, Google's Google email account. Then you select continue. Then you need to select check this one, view and manage your Google's Hongjie data and manage your data permission in cloud storage and see the email address for your Google account. So you need to check both this one. Then you see click continue. Then we will create this code. So you will click this code, which is copy this code, and then you come back here and paste this code here and hit the end. So right now you are finished, successfully saved authorization token. So this is also every time you need. Whoops.
I'm just keeping this in.
Okay.
Alive, so
Okay.
all I see.
Okay. So get that. This one go okay. Just continue. Got it. But you okay with that? Oh, you was okay. Yeah. Yeah. I don't know. I think we don't need actually. So let's follow the step one more time. So just click this code. So I didn't select anything. Oh, yeah. I have created yeah. Okay. So you need to create a project. Yeah, I create. Once you create a project, then you just click generate a token. So then I can pass that part. Then select my email account, Gmail account. Then I will continue. Then I need to select both these two. So
they need to create a project first.
okay. create a project. Oh, it's already this. Oh, yeah. So just, yeah. Oh. So you get okay. Change one. Right. So. Oh, good. Yeah, so it's. So it's approaching me. Oh. Oh, the email should. Oh, okay, okay. Is anybody?
Yeah, they're all set.
Okay, so she's also good. You said it. Okay, good. Okay. So once you give that token, and once you get the token, continue. Select both this. Continue. Then you click this code. Click. It's copied. Then come back to here. Yeah, because I think I already had it here, so I'm fine. I believe already success. So once you finish that, then we go to initialize. Click initialize. Yeah, yes. And then you can to put the map. Okay, so this map right now is the base map is very similar like the JavaScript map. Okay, but this is through the Colab they provide us with the Google engine map we installed here. Okay, so this is the basic map. Every time we will do that. We will overlay our stuff on this. Okay, so you can easily zoom in, zoom out here. Okay, So you can zoom in, zoom out. Okay, and you can select the area of interest. You can select area of interest. Yeah. So we can come back to here, select a different area of interest. Yeah, is yeah. So this is the very first step. Then you can also use the center. So you use the latitude longitude center to select your region of interest. For example, this is one of the center, Houston maybe. Yeah. So you can find the area center. For example, we want to find the Conception for our center. I just copy this and first copy to here, paste to here. Yeah, this is the zone is the size of the how big you want your map to zoom in. Okay, so right now we use 6. So let's execute. Yeah. So Conception is in our center. Okay. Then we can use zone 3, for example. Let's see how big. Oh, I'm sorry. I cannot use that. So I change it to 3 and redo it. Re-execute. Okay, it's smaller. Okay, 3 is smaller. Let's do 10. It's more zooming. Yeah. Yeah, Conception is in our center. So this is something. I think the time is already over. Yeah, 4 o'clock. Yeah. So if you have time, you can go home to go see that. If you don't have time, that's okay. We will continue tomorrow. I think hopefully we can finish all of this the rest of the week and have you will get very interested in start to look at the data, at the animation, lowering different data sets. Okay. Any questions? Okay, good. Yeah. Okay, see you tomorrow.
Yeah, I'll stop
Yeah.
the recording.
Okay. Good.